In this chapter, we are going to talk about templates in C++. This is going to be our last chapter for the syllabus. It's a very simple chapter, a small chapter, so just pay attention to this, and you may get questions from this chapter also in your final exam or end semester examination. So let's look at what exactly is templates in C++. Now, templates is one of the extension that is available in C++, not available in C. Similar to exception handling, templates are the additional features that are allowed or available in C++ programming. Now, these are the things which we are going to actually look into while studying this chapter. So let's first discuss what exactly is the need for templates and why and how are templates useful for us. Now, if you look at an example on the top here, you have a simple function to calculate the maximum of two integers. Now, the code here is pretty simple. It compares two variables which are integers, and it returns the one which basically is the greater of the other. All right. Now, if you look at this function here, it works only for two integers. So if I have to write another function which would work for another data type, that is double, I need to write another function here. So this function basically is a function which is going to use integers, and here it's going to use double. Now, if you notice, both the functions have the same name. That means we are overloading the function. Now, when you have scenarios like this, where your logic is the same and the only thing which differs is your data type, then templates come handy there. Because otherwise what happens is you are having to replicate the same code again and again, only with the difference of a data type. So in this case, if we can replace an integer or basically a double with some kind of placeholder, where we can, at the time of running the code or at the time of compilation, we can replace that placeholder with the kind of data type that we want, then we don't need to have separate copies of the similar code. So let's look at how this is done. So when you have functions, function templates are functions that serve as a pattern. So a template basically is a pattern. It's basically a kind of stencil through which you can replicate or you can make things in a easier way. So function templates are nothing but stencils for creating similar kind of functions. Now, the idea is to create a function without having to specify the exact type or sum of all of the variables. So what basically this means is that when you write a function or when you define a function, we do not use the actual data type, right? But we use the function as a template, and later on we replace the actual data type. Now, when you are using a function where in place of the data type you are replacing with something, you're replacing with placeholder, then these are called as template type parameters. So in your function, we are not actually using the data type, but we are using the template type parameters. I think if you are still confused, it will be clear when we actually look into a code. But how does a function template work? Now, the function template cannot be directly called. The compiler doesn't know how to handle placeholders, directly. So what it does is, the template function, the compiler, when it sees a template function, it stencils out a copy of that and replaces the placeholders with the actual variable type. So in fact, what the compiler does is it cannot process the template function, but from the template function, it actually replaces the type, the placeholder, with the actual data type, and then that function is basically compiled. All right. So let's look at an example of how exactly the function templates work. Now, in the first case, we have a simple function which finds out the maximum of two integers. Now if you look at it, we have an integer here, basically that's the return type, and you have integer here and integer here. Now what we need to do is, in place of these integers, we are going to replace it with a placeholder. So the placeholder that we have used right now is type, right? Now type is a placeholder. Now it can be anything. This placeholder, this type is not a keyword, it's a user defined word. So you can write anything for this type in place of type. However, you should not be using any reserve word, right? So this function will change to this, right, where in place of the data type we replace it with a placeholder. Now if you replace the placeholder with the data type, you basically get from the stencil you get the actual function. So this is like a stencil or a template. All right, now when you declare a type or a placeholder, you also need to inform the compiler that whatever I'm using here, in this case type, is a template type parameter. It's not a normal data type, but it's a template type parameter. So how do we inform the compiler that this type is not a data type but a template type parameter? We inform the compiler by writing this line. This is called as a template parameter declaration. Now it uses the keyword template, and then you have to specify the type name. Basically this type name gives you what is going to be the name of your placeholder. So in this case we have the name of the placeholder as type, so that's why this will work. So if you want to change it to test, you have to write test, test, test. So basically this line tells you, or tells the compiler, that when I'm declaring or defining a function, I am using it as a template function, and the placeholder that I am going to use is type. Right? Now another thing that I want to tell you here is there are two ways in which you can declare the template parameter or this placeholder. One is by using the keyword type name, and the second one is, in place of type name you can also use class. So this line can also be written like this. However, for better understandability, what I would prefer is, whenever we are using a template function, we should use type name, whereas when we use a class template, at that point of time you can write class here. So then it's your way of defining stuff. You can define class for everything, but just to have a clarity that okay, this is a function template and not a class template, you can use type name, and whenever you have a class template you can use class, but you can use both and everything is, it's allowed. All right, now let's look at an example of how a template function works. So I have a template function defined here with the type name is t. So I have written a simple function which basically is calculating the sum of two numbers. Now that number could be an integer, it could be a float, or it could be a double. So in this case I have declared a template. The placeholder's name I have given it as t, and this is my stencil or the template function. Now in the program I have used 3 integers and I have also used 3 floating point. Now in the first case I am calling this template function by passing 2 integers. So when I pass 2 integers, what happens? The compiler, in place of t here, replaces it with the word int. So basically this function, the copy will be created here by replacing t with an int. So when you call this function here, this function is going to get invoked. However, in place of t you are going to have int. So it will work for an integer. Similarly, when I use floating point and I call this function by using f1 and f2, which are floating point, the compiler, what it does is it will create a function by replacing t with float. So that means the body of the function is now going to be with float, float and float. That means you can perform the addition of two floating point numbers. Now what is the advantage of this whole thing? The advantage of the whole thing is you don't have to write this function again and again, once for integers, once for floating point. And that is the whole purpose of templates. Templates will actually help a programmer in reducing his code size. Right? So I hope you understand how a function template is useful. Now next we'll move and we'll look at the same thing. Next we will see how a class can also be created using templates, and we will discuss the class template. A class template also is similar to a function template, and as I told you that you have to declare a template parameter declaration, and you can either use class or you can use type name, but when we use class templates I would prefer to use it as class, so that I know that exactly when I'm declaring a template it's not a function template but a class template. Now what exactly is a class template? Let's look at a simple example of a class called stock. Now in this class stock I have private variables, which is quantity, and we have the second variable which is SP. Right? Now this is QTY and SP. Now if you look at it, I have created a member function here which basically initializes the value to QTY and SP. Now I can have two variations of this. I can create an object where the QTY and SP are integer values, or I can also create an object where QTY and SP are floating point or double. Now if I had that scenario where some objects would have integer values and some objects would have floating point or double, then in case of a program where we don't use a template, we needed to create two versions of the same code here. That means in one code, that means in one of the what you call the constructor, we would need to pass integers, and in another constructor, that means you're overloading the constructor, we would need to pass floating point, and if we needed another one, double, we would need a third constructor, that is with a double floating point. So in order to save from writing all these three different versions of the constructor, we can declare this as a template. And since the member function also takes in the data which needs to be declared, so in this class we declare this data with a template type declaration, right, with a placeholder. So now when we create an object of this class and I specify integers, then look at this syntax here of how you need to use it. So when I want to create an object wherein QTY and SP are integers, I need to specify this int in front here. Alright, now what will happen is integer int will get replaced at all the places where t is there. So you're going to have private int qt, sp, and stock int x and t int y. And this entire constructor will work for an integer. Similarly, if I want to declare an object and I need to pass both the variables as floating point, I need to write float here, and the compiler will take care of it, and it will create another function body or another overloaded constructor in which the parameters are not integer but float. Right? So this is very important, that at object creation, so when you're creating an object, you need to specify what the actual type needs to be, right? So you have in this case an S1 is an object which is going to store the data of integers for QTY and SP, and for the object S2 it is going to store the data of type float. All right, so it's very simple. Now let's look at an example where we have a template with multiple parameters. Here, if you notice that when we use t, that means both of them would either be integers or it would either be float or a double. But if I want one of them to be integers and the other one to be a float, so I need to use a template with multiple parameters. Now it's very simple. When you're declaring a parameter declaration, template parameter declaration, you need to specify differently. So I have t1 and t2 here, right? So let's look at a code of how it works. So in this case now, I have declared that x and y are two different template type parameter. So when I write a function here, I have one which is x and the other one which is y. So what happens here is now I can replace x with one data type and y with another data type. So if I have to create an object, now this is important. So if I have to create an object here, wherein in the first member variable I'm using float, and the second one I'm using integer. So what happens is an object is created where x is replaced by float and y is replaced by integer. In the second case, I am replacing x using char and y using double. In the third case, I can use x as an integer and y as a double. So even function templates can be defined with multiple arguments. Now this is what a class template with multiple parameter means. So you can have as many placeholders as you wish, and you can replace each one of them with different data types. So you can have a combination of parameters in your code in your template class. Similar to a class template with multiple parameters, you can also have multiple parameters in your function template. So if you look at this code here, we have a simple function and I've declared two parameters, two type name. One is x and one is y, and you can write this function and you can call this function by using a combination of different data types. In the first case, I've used x as a character and the second was as an integer, and in the second case I've used x as a floating point and y as a character. So x and y will be replaced accordingly. You can also overload the template function. So template functions can be overloaded just like your normal ordinary functions. What the compiler does is it first searches for the exact match, and if it finds, it invokes it. Otherwise it searches for the template function, and if none of the versions are found, there is an error which is thrown. So if you look at an example, I have a template function which is void display, and I am overloading that with another display, right? So what happens is when you look at this main method, when I pass a, it first looks at it looks at the code here, and I'm sorry, not this one. When I pass a as a character, it actually looks at this. It does not find any display with where the character is used, so it invokes the template function. And in the second case, when I'm passing a float, it first looks for a version where float is passed and void display is invoked. Now the class template, the member functions in a class template can also be declared and defined outside the class, like how you define those functions inside and outside the class. Similarly, you can also define member function templates outside. So how do you do it? Here is a simple example. So I have declared a template type parameter here. However, using the scope resolution operator here, I am defining the template outside the class. This is not quite important, but just make a note of it. So this is where the template ends. So it's a very simple small chapter. If you know how to use it, you can use it in multiple ways. You just need to know what exactly is the placeholder. How do you define a template type parameter? And that's more important. So if you can write a function and you know exactly how the placeholders work, it is easy. And you can use it inside a class, you can use it with a class, you can use it as a normal function, and wherever you find that their function code is being repeated or the function versions are only changing because of the different data types, you can use template function. Don't focus too much on this because this is not a part of object-oriented programming. What you need to focus is all the concepts of object-oriented programming that we have discussed, which involves abstraction, encapsulation, inheritance, and polymorphism. So those are your key chapters. These are add-ons. You can practice, write a small code and see exactly how the template parameter and the template functions and template class templates work, and I think that should be fine. So all the best for your final exam. If you have any queries, please ask me directly on WhatsApp, and I hope this semester has been fruitful. I know we've had a little bit of uncertainty at the end, but finally we have made it. So all the best for your exams, and see you soon.